Hi there, this is lesson 3.5, parallel lines in triangles. So I want you to get out your video notes and let's go through them. Okay, so here's our three vocabulary words. We're going to get to exterior angle of a polygon and remote interior angles in just a minute. So let's talk about auxiliary lines. So it's basically a line that we can add to a diagram to help us explain the relationship in a proof. That's all it is. So in this lesson, we're going to understand about angle measures of a triangle, that they're always the same. So let's first start with some postulates that are really important. So postulate 3.2 is called the parallel postulate. And what we need to know here is that through a point, not on a line, there is one and only one line parallel to the given line. So here, there's exactly one line through P that is parallel to line L. The triangle sum theorem, you've already learned this. So basically it says the sum of the measures of a triangle is 180 degrees. So measure A plus measure B plus measure angle C equals 180 degrees. Now let's look at a key concept, which we're going to have our other two vocabulary words. So an exterior angle of a polygon is basically, it's an angle formed by side of the triangle, so like right here, and an extension of the adjacent side. So this side is adjacent, so it's an extension. So this angle right here is called the exterior angle of a polygon. And we're not restricted to just triangles. Now, so for each exterior angle of a triangle, the two non-adjacent interior angles, so here's the exterior angle. This angle right here, as you can see by angle 1, which makes a linear pair, is an adjacent angle. The other two angles of the triangle that are not adjacent are called remote interior angles. So in each triangle below, angle 1 is an exterior angle and 2 and 3 are remote. So if we extend this, 2 and 3 are remote. Here we extend this one back here. 1 is the exterior angle and here's 2 and 3. And if we extend this side out, 1 becomes the exterior angle, and then here's now angle 2 and 3, which are the remote interior angles. Why is that important? Because now we get to our theorem 3.12, which says triangle exterior angle theorem, which says the measure of angle 1, the exterior angle, is equal to the remote interior angles, measure of angle 2 plus the measure of angle 3. That's really important. All right, so let's look at problem 1. We're proving the triangle sum theorem. So that's this one up here. It says that they're equal to 180. So they want to write a two-column proof proving the triangle sum theorem. So we want to prove that angle x plus angle 2 plus angle y equals 180 degrees. So given the triangle x, y, z, that's all they gave us, x, y, z. So we're going to use an auxiliary line. So let's go to here and go through the book and go through the proof. So we have our statements and our reasons. So we need to prove that these angles equal 180 degrees. So we first draw line AB through Z and parallel to XY. All right, so we name A and B. So we're using the parallel postulate, right? That says there's exactly one and only one. That's this first one right here. And we're drawing an auxiliary line. Next, we can say the measure of angle 1 and the measure of angle x, y, b are supplementary because of the linear pair postulate, right? They make, so it's this big angle here and angle 1. Then we can say the measure of angle 1 plus the measure of angle x, z, b equals 180 because the definition of supplementary angles. Then we can say the measure of angle x, ZD is equal to the measure of angle 2 plus the measure of angle 3. And this is the angle addition postulate that we learned in chapter 1. Then we can say that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equal 180 because of the substitution property. So we just substituted measure of angle 2 plus measure of angle 3 in line 3 for the measure of angle x, ZB. That's here. So that was the substitution property. Then we can say the measure of angle 1 is congruent to the measure of angle X, and the measure of angle 3 is congruent to the measure of angle Y, because remember we said XY is parallel to line AB, and if you have a transversal, then line 1 and angle 1 and angle X are alternate interior angles, and angle 3 and angle Y are also alternate interior angles. So that's why they're congruent, because of the alternate interior angles. Then we can say the measure of angle 1 equals the measure of angle X and measure 3. So we went from congruency to equal by using the definition of congruent angles. And then we can just do what? Use the substitution property. So the measure of angle X plus measure of angle 2 plus measure of angle Y equals 180 for the substitution property. And now we've proved that theorem. Okay, let's look at measure angle 2. So here it says, what are the values of X and Y at the diagram? So we have our triangles. So we have triangle ABD. They give us angle B is 43 and angle A is 59. So can we find the measure of angle X? Yes, because we know that the three angles have to equal 180. So we write our equation and we solve using algebra, and we get X equals 78. Then we need to find the measure of angle Y. Well, they give us only give us one angle value, and we need two to find the third one. But look at angle X and Y, they're a linear pair. So if angle X is 78, we just subtract that from 180 and we get Y is 102. And then if we needed to find Z, we just add 102 plus 49 and subtract it from 180, and we get Z is 29 degrees. But they didn't ask us to find it, but they could have. Let's look at problem 3. Whoops. They want us to find what is the measure of angle 1. Well, you have a triangle. You've got two of the three angles. Can I find this third angle? Yes. Or I can add these together and subtract from 180 to get this angle. Well, what do we know? Angle 1 is an exterior angle, and the 80-degree angle and the 18-degree angle are the remote interior angles. And we know that they're equal to the exterior angle. So all we have to do is add 80 plus 18, and we get the measure of angle 1, which is 98 degrees. Look at B. So we know that the 59 degrees angle and the angle 2 are what? Remote interior angles, and they're equal to the exterior angle, which is 124. So we can just set these equal to each other and solve, and we get the measure of angle 2 is simply 65 degrees. Okay. Let's look at the last problem. Yes. So it says applying the angle theorems. So multiple choice. So when radar tracks an object, the reflection of signals off the ground can result in clutter. Clutter causes the receiver to confuse the real object with its reflection, called a ghost. At the right, there's a radar. Receiver A, an airplane at B, and the airplane's ghost at D. They want us to find the value of X. Well, I know, here's my triangle. I only have one angle, so I can't find it based on that information. However, I have an exterior angle. So I know that that is equal to the angle B plus angle A. So I can say 80 equals X plus 30, and I can solve using algebra, and X is 50 degrees. All right, so this, just knowing those theorems, and you can apply this and solve for a missing value of the triangle or its exterior angle. All right, so stop the video and do the problems that are assigned, and we'll see you in class.